All right, thanks everybody for coming to the talk. UTXOracle is an open source program that anybody can run from their own node to get the Bitcoin price directly from their node without going to a third party. So it fits kind of nicely into the privacy theme of the conference, not having to contact an external source. Just so I know how much background it gives, is anybody like first time hearing about UTXOracle, or you generally have heard about it? First time heard about it? Okay, I'll give a little background on it. A common problem with checking the Bitcoin price is you got to go to a website, you got to pull up an app, you got to go to an exchange. Maybe this exchange doesn't work in your country, and maybe the API that you're using to get the Bitcoin price is kind of wrong. So this program just lets you get the price from the node itself. Kind of just another one of those third-party programs that we can cut out. But in this presentation, I'm going to try to convince you of something a little bit more important than that. I'm going to argue the thesis here that the historical Bitcoin price chart will be the on-chain price. So what defines what was the Bitcoin price over the past decade will not be a record that comes from Coinbase or from some source. The signal that is on chain for the Bitcoin price will become known as the reference price, or just what the price was. So I'll see if I'll be successful in convincing you of that. Gonna do this talk in 4 parts. First of all, how in the world is the price even on chain to begin with? Then I'm gonna do a little demonstration where I just download the program and run it. Just takes about 30 seconds to run, depending on your, how fast your computer is. Number 3, I'm going to get a little abstract and talk about the philosophy of code, just about kind of different kinds of code and how UTXOracle is more in the Bitcoin philosophy. And Bitcoin did not solve the Byzantine generals problem directly. It solved it through a kind of soft consensus statistical way, and that's how UTXOracle goes about solving the Oracle problem. And finally, I'll wrap up with FAQs, criticisms, and benefits. This isn't brand new. It's been around a while, so I've had time to get all the criticisms on Twitter and stuff. Been responding to those, so I'll just go over a few of those common ones. If you have any others, though, feel free to ask them. How in the world is the price even on chain to begin with? The way I'm going to do this in this section is not even going to show anything about UTXOracle in this section. Everything I'm about to show is just RPC get block. This is just information that you get from your node. So no Oracle stuff right here. And I think the easiest way to show this is to just do a chart of every Bitcoin transactions that has ever happened. So just going to take a second to go through these axes here, because sometimes people stumble on it. This is the date that the transaction occurred, obviously 2009, 2025. And this is the amount of Bitcoin in the transaction, specifically the transaction outputs. So every transaction output that's ever been transacted on Bitcoin will be in this chart somewhere. The y-axis there goes from 0 sats. We've got some op returns at 0 sats all the way up to 1 million Bitcoin. There's always a controversy over how you denominate small amounts of Bitcoin. Sorry, I didn't use millibits or megasats or whatever the trend is these days. I put the cutoff right here. So 10K sats right here, 0.001 Bitcoin right there. When I first started making these charts, I didn't really make this y-axis high enough. They might know what the largest amount of Bitcoin in a single output has ever been. It's actually 500,000 Bitcoin in 2011, but we have not had an output over 1 million Bitcoin. But just take a second. So what I'm going to do is going to load the first half of this chart. Think about what you expect to see here. Satoshi's outputs right here. Early Bitcoin activity, how finished transactions. Here are all the transactions up until 2015. So this is what we expected to see. 50 Bitcoin right here. Remember that this is log scale, so we're jumping up powers of 10 here. Early Bitcoin transactions, there was that 500,000 transaction right there in 2011. You can see a little bit of zero return outputs in the beginning. The dust limit, if you remember, is around 500 Satoshis, a little bit less for SegWit, but it's going to be around this area, but it didn't really get started until later on. And you can see that the most common Bitcoin output is 0.01. So the resolution of this grid here, obviously I can't have a pixel for every single block. The resolution is monthly on the time axis, so like 12 steps in between each one here. And on this graph, I'm going to dial in and get higher resolutions as we go on. But on this graph, I've got 10% in the Bitcoin range, so 10 steps in between each power of 2 there. And so what do we see here? We see that very little in the beginning, 2012, 2013, we started getting in the green area. Gray is 1 output, purple is 500,000, yellow is 1 million. It'll get hot here as we go later on. Green is, in the area of maybe 100,000 or something like that. But pretty few transactions early on. Do you guys have an idea of what will happen when I load the rest of this stuff? Down? Yeah. So it's going to get hot, but I remember early in Bitcoin days, we all thought like, yeah, no one's going to spend smaller amounts of Bitcoin, or it's only going to be these nation states settling billion-dollar transactions online or on chain. This hasn't really happened. So if you haven't seen these charts before, you might be surprised at exactly what happened though. So here is every Bitcoin transaction to date. Starting in around 2016, 2017, maybe a little bit earlier, what happened was that phone wallets started giving you the option to just denominate your transaction in fiat instead of in Bitcoin. So right here, everybody was doing round amounts of Bitcoin. No matter what, people like round amounts, whether that's round amount of Bitcoin or round amount of fiat. Like 90% of transactions are in round amount of something. That's just kind of a human behavior. So you can see people sending a whole Bitcoin kind of peaked right here. Kind of not as many people send a whole Bitcoin anymore. A lot of people sent 0.01 Bitcoin back in the 2018, 2019 area, not as much as anymore. 0.001 is actually the most common amount now. Just a couple of these other things on the edges before we dive into the middle part here. Interestingly, the most Bitcoin that people send hasn't really changed very much. If you look at how this dies off at the top, it's interesting that this is kind of the same. We've got the dust limit. That was really good at restricting low outputs. Now we're in, well, what are we calling it? Sub dust limit summer or something like that. So we see a little bit more dust limit activity, below dust limit activity here. This low area right here is mostly inscriptions that were really popular. 2023, 2024, not as much anymore, but that's all this activity here. But I think it's kind of hard to argue that when you just look at like, okay, what's the first thing you see on the map of all transactions ever? There's really only one thing happening, and that is this, which is the price of Bitcoin. This is obviously the primary feature of the blockchain. Like when people are deciding how much Bitcoin they want to spend, the number one and 99% reason of what output they chose was the price. And that's exactly what this shows here. So why do people send 0.001 a lot right now? Because that's what? $100. People have always spent $100. No matter what Bitcoin amount that is, that's what people want to spend. So we're going to dive more deeply into this region here, and I'm going to show you how the UTXOracle operates on a higher resolution of this area. But before we get in just specifically the USD price, like just think about it in terms of purchasing power. So my vision for UTXOracle isn't so much about the USD price as it is just the price of houses, the price of steaks. How do we track the purchasing power of Bitcoin just using Bitcoin itself? And I think this is like the way to do it. So when I zoom in on this region here, I'm also going to flip the axis upside down just because we're all used to seeing that nice price chart going up. So this next graph is not going to change the Bitcoin amount, it's just going to flip them on their head. So now we're looking at 2015 to 2025 at a weekly resolution and a 1% change in Bitcoin amount here. And this is every transaction that has happened in that region, in that range. And I think it's pretty striking that these price lines appear so well. I can go ahead and load a price on here, and please forgive me, I got this price from a third party. Got this price from a centralized source, and even worse, I got this price from the US Fed. So in America now, if you're like a lawyer and you need some official price for a court case of the Bitcoin price, and it needs to be official, what you do is you go to the Fed has a website, the St. Louis Fed. It's the same website that gives you those money supply charts, you know, it looks all official. They just get theirs from an API from Coinbase, but this is the official Bitcoin price. And I hopefully, you know, you won't argue with me that these indeed have to be people's spending amounts related to the Bitcoin price. I think it's kind of hard to argue that that's not. While we're on this chart, number one frequently asked question, especially in Europe, is it only dollars? Like, do you see euros? Again, my primary answer to that is like, I'm just interested in fiat prices. I don't really care. But because whatever reason, US dollars used internationally or whatever, 90% of these round amount prices, probably like 95%, are the US dollar. It could be that they're highly correlated, but I mean, just look, the US dollar and the euro are correlated, but they're not that correlated. I mean, haven't they changed like 20% this year or something like this? So I think if you were to see it as another strong currency, it would show up here. And it really just doesn't, for better or worse. So now I'm going to walk you through the step-by-step process where I try to clean up this signal. I try to make the price lines appear more clearly, and then I run the algorithm on it. The first step is to just remove taproot. So this noise right here was my first problem. How do I get rid of that? Just remove taproot. We take away a little bit of the signal, the price signal there, but that also gets rid of like 90% of what I call noise. One person's noise is another person's treasure. I get that, but for my purpose here, I'm trying to find the price, so that's stuff I want to remove. The next step is I just remove round amount of Bitcoin. This is kind of easier said than done in a way, because sometimes round amount of Bitcoin is the same thing as round amount of dollars, especially when you're like right at $100,000 or something like that. Since I'm doing this in grid histogram bins, what I did here is just averaged over the two bins neighbors. Another way you could do it is look at the entropy of the digits of the output. People spending around Bitcoin, if you just run a Shannon entropy calculation, that's kind of a low or a low amount of entropy, whereas someone that's converting from dollars is going to have a high amount of entropy. That's probably going to be built into the next version of UTXOracle. Next thing I do is I remove transactions that are like batch transactions, consolidations, mixes. I found that like transactions that have a ton of inputs and a ton of outputs don't really add a lot to finding the price, so I remove those. And then the last thing I do is I don't really care about the raw amount of transactions. What I'm looking for is proportions. I'm looking at like what percent people spend $100 versus not $100. So instead of looking at raw amounts, I just convert this to daily totals. So this is the weekly percentage of people spending UTXOs at different amounts. Projector's not making this look as nice as it looks on my laptop, but I can promise you as you zoom in, these lines get cleaner and cleaner. So the next question is, which round amount is which? What is that? Is that $25? Is that $50? Is that $40? Like, how do you know which is which? This is the one sense in that I do use a rough estimate of what I know the U.S. dollar price to be. But common misconception in UTXOracle is that I use some Bitcoin price as a seed and I start it there and I see where it goes. That's not how it works. The only way in which I use external knowledge of the Bitcoin price is just by knowing what this entire line is. So all I have to do is I know that generally Bitcoin was something around $1,000 right here. And Bitcoin was something around $10,000 right there. And Bitcoin was something around $100,000 right there. Just general sense. Once you know that, all you have to do is multiply. So what's $100,000 times 0.001? That's $100. You can do the same thing right here, same thing down here. This is $100. Do the same thing there. That's $50. Go up, one decade from 100, you get to 10. Go the other direction, one decade from 100, you get to 1,000. 10,000, I think, is down here. Pretty much all round amounts are visible somewhere. So now that I have that knowledge, what I did is I went back and I wanted to say just like, what is a prototypical day? Like if you were just going to say like, okay, just make a graph and just show like the ideal Bitcoin day of people spending different percentages of round amount of USD, what would that look like? And the way to do that is just go back and just add all these up and just take the average and see what the average day is. So that is what happens when you look at what the average Bitcoin spending day of USD is. Most people spend $100. Second most is $50. The percentage here is 1%, but remember, this is kind of a subset of the overall data set, and I already removed a lot of data in my filtering. Also, there's a number of data points on this spike here. So there's probably like 5. You have to consider the width of the spike here. Yeah, that's the euro right there. Yeah, right next to it. So, if someone were to ask me, like, what do I guess, what percentage of Bitcoin transactions are people spending exactly $100? It's like 5 to 10%. It's a lot. And that's just $50. That's just 100. You also have 50 right here, $20, $10, $5, $200. These are the common ones that I see, $1,000, all the way up to $10,000, and even down to $1. So something interesting is like even though transaction fees were over $1, people were still sending $1. I think I still sent $1 a couple of times just to prove to somebody. Sometimes it's not all about just wasting $1. Sometimes it's just about showing some noob that it works, and you just want to pay $2 to send a $1 transaction. So that was still happening. Another thing I want to point out about this chart is, like, don't look at the spikes for a second. Look at this. Look at this bell curve. It's not a coincidence that this bell curve is centered around exactly $100. Sometimes you don't even need the spikes. Like sometimes you can just look at the bell curve and say, like, what is the center of the bell curve? And that'll tell you exactly what the Bitcoin price is. Just the general nature of people spending Bitcoin, the center of that thing is always going to be reflective of the average purchasing power of Bitcoin. And that doesn't have anything to do with US dollars or euros or whatever. It just has to do with purchasing power. Yeah. Oh, that'd be interesting. Yeah. I have not tried to do that, but that's a good idea. Yeah, there's a lot of stuff I want to do with foreign currencies. It's just that it's almost, the same way that I removed the Bitcoin amount, the round Bitcoin amounts, it's almost like I need to remove the US dollar and see what's left over. But what you're saying is just look at the, yeah, 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 that's a good idea. Yeah, I'll check that out. Any more questions about this part? Because now I'm going to move into a demo of like how you can run that. Yeah. Yeah. Yeah, it generates a web page. I'll show you that in the next section. Yeah. Yeah, so I only do it one day at a time. To run these kind of charts that I'm doing right now takes, yeah, it's like syncing a node, So I just showed you like the price of yesterday or something. Yeah. hmm it's an option. Let me show it to you. I'm about to get to it. Yeah. Yeah. It was growing. Uh, Taproot transactions were growing like crazy for the past 2 years, but it seems that they're dying down a little bit. There's an interesting report from the guy Orange Surf at mempool.space who just looks at the value, the total value in different address formats, and it's pretty clear that Taproot is only used for very small value transactions. But I think it's on the decline, or maybe Taproot will just be used for larger transactions. Yeah, yeah, I think so. Okay, so the next part of this, we're going to get into more of a demonstration. Oh, actually, let me give you one more just kind of brief visual. This will just take a couple seconds for how the algorithm works. There's a lot of ways that you could go from this knowledge of what a prototypical transaction day is to some kind of algorithm that searches for where this fits on the data every day. There's probably a million ways to do it. The way I've decided to do it for the versions is just by superimposing this kind of thing on top of the data on a single day and just sliding it down. How well does that fit there? It's really like a very simple way to do it. So you just slide this down, see where it fits best. It fits best there. Once you know where this fits, then you know what $100 of Bitcoin was at. So $100 is this amount of Bitcoin. Just divide, and then you get a price. Do this on every single day. I've done this on every single day back to 2020, and it works pretty well. And so if I compare these two, I've made the Bitcoin price a little bit wider here so you can see where the UTXOracle fits, and it's dead center. So there's no real difference when you consider that price itself has variation. Like there's different exchanges have different prices. There's open price, closed price, high price, low price, and every exchange has all of these. They're all different. So within the variations of the exchanges themselves, like UTX Oracle is no different. And the longer I think about this, UTX Oracle, when you think about when people are making on-chain transactions for around USD, they themselves are getting this price from somewhere. So it would make sense that UTX Oracle is already a very natural average of all the exchange prices. And like one step further is that like the people who are doing this are people who know how to make a Bitcoin transaction, which is a small, very knowledgeable subset of the people that buy Bitcoin. So this is an average that's taking from every price source that people can use, probably more that get into cell phones, and it's the average done by people who know how to use Bitcoin. So it's kind of a nice subset and averaging of the exchange prices. All right. So now hopefully I'll answer some of your questions here. I'm going to run this from the node. Yeah, my GitHub is unbelievable. I also have this hosted on my website. which you can get to. I bought the domain UTXO.pro. I'm glad I got that before. Isn't there a company called UTXO now? I'm glad I got that domain before they did. Simplest way to download it is just use the curl command on your terminal, and then you can run it with one command. Curl. Yeah. Run it with curl command. Okay, so let me make this window a little bigger here. All right, so I am in a fresh directory here. I just cleared it out. The only thing that I have like installation-wise is Python. So if I do Python 3 version, you have to have Python 3 or greater. That's the only thing you need. There are no third-party dependencies in here. There's not even a pip install. Like, of course, I should have used, and I do use myself, NumPy to do all the like crazy histogram heat map stuff. I just hate making people install third party, so I just rewrote all the programs that I needed to write in just vanilla Python, just to make it easy for everyone. So you can go from not having UTXOracle on your computer to having UTXOracle computer by just typing this command. It takes a whole 1 second. UTXOracle is now installed on your computer and ready to go. And then you can just run it Python 3 UTXOracle.py. Like I said, it runs pretty quickly. Connects to your node, use RPC, your like default cookie credentials, finds the first blocks. This runs yesterday by default. I'll run it in recent block mode as well. It loads every transaction for every block, so just think about every block's 1 megabyte or whatever. It's loading 144 blocks, so it's doing kind of a lot. Yep. Yeah, it does. So I've experimented with so many different ways of doing that. Let this price pop up real quick, and I'll show you. So right now it's trying to locate the center price. After it does that, it's going to make an HTML page and serve it up here. So this just automatically runs. It just opens up that in your browser, and this is the price from yesterday. So all of this data was data that came from your node. Every dot is an output. The algorithm has found that these are the outputs that have US dollar price information in them from all different round numbers, so US dollar, $50, or everything. And you can see that that price line, this is actually kind of a noisy day. A lot of times the price line is more clear than this. And then the reason I'm quoting 114,097 as the consensus price is that after I get all of the price points and I put them in some reasonable estimate of the price that was found by that stencil gliding algorithm, that thing's not perfect, but it'll get you within 5%. After you get a good rough estimate, just put all those points together, just throw them and just say that's the price, then make that plot. If that price wasn't perfect, then this thing won't be in the middle. This thing will be like up here or down here. So then I have an iterative algorithm that just constantly looks for the median and recenters. So what was the median of all of these prices? If it's up here, shift this entire thing down to the middle, pull in more prices from the top, pull in more prices from the bottom, calculate the median again. If it's moved, then shift again, and just keep doing this until the median converges. So when you do this, one of two things is going to happen. Either it's going to converge on a stable price, or it's going to oscillate between two prices. So like the first time it repeats a price, just call that the central price, which is kind of cool because that means that the thing I'm going to quote as the consensus price for the day is an actual Bitcoin transaction. So somebody won the award for defining the central price of the day. So this is how I dial into like a very accurate estimate of the price. And I was going to get back to your question about, oh yeah, what does it generate? Um, so yeah, so let me just show you this. So well, all this does in this directory now is just UTXOracle.py and the HTML file that it generated that shows the chart. Um, the script itself is, if you want to look at it on my GitHub, I guess you were just looking at this. Yeah. Yeah. Oh, the heat maps are very data intensive. To generate that heat map, I have a lot of efficiencies built in. Like I've written my own SQL servers that I store the blockchain in different ways, and so like just generating the heat maps from a Bitcoin node yourself probably going to take about like a week of runtime. Um, that's fine. Okay. Yeah, I mean, I can make that kind of stuff available if people want it. Each month. Yeah. Sure. Yeah. Yeah. I have noticed that like heat maps, people like my heat maps more than anything else I post. So, I mean, my dream is to have this kind of crazy website where you can just zoom in like Google Maps, like Google Earth style, just zoom into different. Yeah. 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 For that, I would just probably go with a different Python script that I've written. I probably wouldn't use this one. Um, yeah, right. The website has the graph. The heat maps don't come from UTX Oracle at all. Yeah, it's UTX. The heat maps come from my SQL server where I just have the data nicely formatted. While I'm on this UTXOracle.py script, one of the things about this code is I wrote it like academic style, like just kind of there's a table of contents, so the script just proceeds like top to bottom. You don't have to like jump around to functions or anything. Each step of the algorithm is just listed by line number, so you can just scroll down to the line number that you're interested in if you want to see how that step works. Um, no, I don't have easy median calculation in this script. No. Let me just run this one more time though. So if you type in UTX Python UTX Oracle.py -h, this gives you the help. There's only a couple options right here, but I let you run it on whatever day you want to. Going back, I think this version goes back to 2023. If you want earlier than that, you probably need to use earlier versions. If you got a weird path to your directory, oh yeah, that was the other question you asked. So, how do you get access to how do you write a program that gets access to the user's directory and their configuration file and their blocks file and just has an RPC password and a cookie? Like, there's a million ways to do this, but through a lot of research, it seems like the easiest way to do it is just to look for the cookie file that's automatically generated the first time you make an RPC request. So now in current versions of Core, enable RPC. RPC is enabled by default, so RPC server. And what happens is the first time you call it, if you have not set up a username or password or made a cookie file, it makes one for you. If you did, then this thing will search through all of the directories that should possibly contain it. So yeah, it'll read your config file. It'll look for your cookie directories. It'll try to find it somewhere. Yeah. Is, yeah, Pi Bitcoin kernel. Okay. Okay. Sweet. Yeah. It sounds like a pip install. Yeah, there are no pip installs. There will never be any pip installs in UTXOracle. No third parties. Okay. Yeah. Yeah. So I plan on like adding libraries like that when I make integrations. Yeah, I think something like that would be really good, especially if you're integrating. People are like, "Have you integrated with Start 9 yet?" When I start integrating with Start 9, it's just pip install, pip install. So it's like something like that would be like pretty good when integrating with other products, I think. But just for this kind of version, I'm going to keep this version as clean as possible, even if it runs slower. Yeah. Okay. Yeah. No worries. Yeah. No, I probably will end up using stuff like that when I work with other projects. Yeah. About to go. Okay. 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 Sounds great. Thank you. All right. So let me just skip forward a little bit in the presentation. Go back to this. Let me just breeze through what I was kind of interested in telling you guys about earlier, how UTXOracle shares Bitcoin's design philosophy. What did Bitcoin say? What's the problem with money? All the trust in third parties. That's the problem with money. Same with UTXOracle. It tries to cut out the third-party price provider. What does Bitcoin assume about humanity? That nodes will be acting honestly. At 51% of the nodes have to act honestly. UTXOracle depends on people spending honestly. Actually, that was that last one. Oh, the natural human tendencies. Yeah. Natural tendency for miners to self-interested profit. Not natural human tendency for people to spend in round numbers. Like I said, we assume they spend honestly. Confidence with confirmations. You can't get the price in one block of data. You need lots of data to get the price. The more blocks of data you have, the more accurate your price. Same thing with transaction finality. Sometimes you have to wait 6 blocks before people are sure that your transaction went through. And finally, Byzantine's general problem was solved by Bitcoin in the same way that UTXOracle solves the Oracle problem. So it's not a direct solution to the Oracle problem. But if you look at averages, you look at emergent consensus, I think this will end up being the way people think that the Oracle problem was solved. I went through a lot of these FAQs and criticisms already, so I'll just go ahead and like just breeze through them. Can't wait till US dies. Happy for it. Currencies besides USD, not really. Maybe we can figure it out somewhere, but the bigger deal is that the broad curve tracks purchasing power. Will people always spend around USD amounts? This is an advertisement for the Honey Badger conference tomorrow, the most OG cypherpunk Bitcoin conference in the world. Round amount of fiat. Everyone will always spend in round numbers. Is it gameable? The one thing that's cool about the gameability of UTXOracle is we kind of know how much it costs. It's going to be a function of the transaction fees that you have to run. There's 500,000 outputs per day. Most of those contain price information. You got to outrun that benefit. So like this is a mutable, accessible historical price record that merged through decentralized people acting. Not one person wrote this price. You don't have to use an API or trusted third party to find out about it. For privacy's sake, you can use your own sovereign node. This is open source code. One thing that I mentioned a little bit, but not very much, is that there's no paper trading. If there's flash crashes on the exchanges, maybe people who make on-chain transactions aren't going to make on-chain transactions. So maybe you see less volatility with crazy things happening in this price because there's no paper trading prices. There's a Bitcoin transaction for every price point. So in conclusion, is the price on chain? Yes. The price is kind of the only thing on chain. Like the reason people choose their Bitcoin amounts is because of price. That is the number one thing that decides how much Bitcoin people send is price. Run it yourself. I showed you how you can run it yourself and see it. I've argued that UTXOracle is a statistical solution to the Oracle problem. And when historians ask what the price was 10 years later, My hypothesis is that they're not going to ask Coinbase. They're not going to use the API. The answer is very clearly on chain, and so that's what like the historical record will use. So, thanks, appreciate it.